Today we've got a modular arithmetic style question. The question reads the following: what is the smallest number that leaves a remainder of 1 when divided by 2, leaves a remainder of 2 when divided by 3, leaves a remainder of 3 when divided by 4, and so on, up to leaving a remainder of 10 when divided by 10. So let's start off by calling this smallest number x. And in terms of modular arithmetic, we can say x is congruent to, so when divided by 2 leaves a remainder of 1, so x is congruent to 1 mod 2. And we can say this the same for x is congruent to 2 mod 3. And then we go on up until mod 10. So 8, 9, 5, 6, 7, 8, 9, 10. We can say x is congruent to all of these. Now, we know that x is congruent to all of these, but you can't really go nowhere from here, but there's no direct link between all of our expressions. So using congruency, we can make a link. So we can say when x is congruent to 1 mod 2, x is also congruent to minus 1 mod 2. Right, we can see it like this. If we've got 1, 2, 3, 4, 5, 6, 7, 8, and we've got 5 mod 2, we can say that it's 1 greater than a multiple of 2 plus 1. It's also 1 less. And this applies for any of the other mods in this case, so we can say x mod 3 is congruent to minus 1, and so on and so forth, up until x is congruent to 10 mod minus 1. So now we can create expressions. So x equals 2k minus 1, 3k minus 1, so on and so forth, up until 10k minus 1. So we know that x is 1 less than a number that is divisible by 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we need to find the smallest number that is divisible by 2 up until 10. So the best way to start off with this is by using all the primes, so 2, 3, 5, and 7. Now if we bring this list down as a sort of checklist of our factors, we've eliminated 2, 3, 5. This should not be a 6, it should be 7. Alright, so since our number is a multiple of 2 and 3, it must be a multiple of 6. It's a multiple of 2 and 5, meaning it must be a multiple of 10. Now we just need to make this number, when I say this number, we're taking the product of 2, 3, 5, and 7. So we need to make sure that this number is a multiple of 4, 8, and 9. To get a 4, well, we've already got 1, 2, so we just introduce another 2, times 3, times 5, times 7. So that's 4 gone. The same with 8, we just introduce another 2. Now we've got 2 cubed, times 3, times 5, times 7. And for 9, well, we've already got 1, 3, we know 9 is equal to 3 squared, so we just raise the power by 1. Now we need to evaluate this. So we've got 8 times 9 times 5 times 7. We've got 63 here times 8. 63 times 8 is 504. Now we've got 504 times 5, which is 540 divided by 2, which is 2520. Now we said x is 1 less than a number that has factors 2 up until 10. So all we have to say now is x equals 2520 minus 1, which is 2519. Now we can quickly check that this number actually satisfies the inequality, and the inequality is the congruences. So if we have mod 2, we do get 1, because it's 1 larger than even. Mod 3, well, if we do 2519 divided by 3, we've got 8 times 1, we've got 7 remainder 2, so this checks out as well. Mod 4. So we already know that 2500 is a multiple of 4, because it ends in 2 zeros. So we've got 19 to deal with, and 19 mod 4 is 3, which works out again. Mod 5. This is easy to work with. We know 2519 is 4 larger than multiple of 5, so that works. Let's go over to mod 6. Well, if we quickly do 2519 divided by 6, we've got 156 remainder 5. Again, this works. Mod 7. Again, we just have to use the division. So we've got 3 remainder 4, 5 remainder 6, and we've got 9 remainder 6. Mod 8, 2519. Well, we know. Well, we can just quickly do a division. 1, 3, 4, remainder 7. Mod 9. So 2519 divided by 9 is mod 2. Sorry, it's 2 remainder 7. 7 remainder 8. 9 remainder 8. So again, this works. On mod 10. Oh, this is an easy one to check. If it ends in a 9, then it has to be congruent to 9. So we've just checked that this number here, 2519, satisfies the conditions for the questions. So we can say that this is the smallest possible number that satisfies the question. Hope you enjoyed this video. See you in the next.